right, I've got another problem up here on the board, and this is in the section where we're looking at what happens if we don't have a perfect match. So should come as no surprise, we're not going to have a perfect match here. Now I do see a product of two functions, and I see that this one is a composition. So I'm going to let u be the inside part. I'm going to let u be cosine of x. Then u prime is negative sine x, which I don't exactly have. I have sine x, but I'm missing that negative sign. Okay. So if I'm missing something, if what I'm missing is a constant, that's just a factor of -1. If what I'm missing is a constant, that's an easy fix. Because what I can do is I can multiply by 1 in the form of, I'm going to just give myself a little bit more space here. This was the integral from 0 to pi over 2. I'm going to multiply by 1 in the form of -1 times -1. That's just 1. So I can introduce what I was missing there. Now, this -1 in sine x can get absorbed into the du, because du would be negative sine x dx. Okay. This is an extra constant, but I can factor constants out. Now that's super important. Here I was missing the constant factor of -1, so I could just introduce -1 times -1, which is 1, okay, and I can factor out the extra one because it's a constant. If I had been missing the sine x, this would not have worked, for two reasons actually. First of all, I can't multiply by 1 in the form of sine x over sine x, because 0 is in my interval, and sine of 0 would be 0. So I can't have sine x in the denominator. But more importantly, well, not more importantly, that's very important. Also, and something that will be true all the time, if I'm missing the variable part, even if I'm allowed to multiply by 1 in the form of what I'm missing over itself, I can't factor variables outside of an integral. I can factor constants out. So, if I have what I need for my du, missing a constant, not a problem. Introduce 1 in the form of that constant over itself, or in this case, -1 times -1, which is the same as -1 over -1, and then you've got what you need. But if you're missing the variable part of u prime, it's a much tougher problem, and probably a u substitution isn't going to work. Okay. So now I'm going to factor out that extra -1. We're going to be integrating from the u value of 0, which is cosine of 0, that's 1, to the u value at pi over 2 is cosine of pi over 2, that's 0. Notice, we're now integrating backwards. My lower limit of integration is bigger than my upper limit of integration. Again, when we first defined that, and we said integrating from right to left instead of from left to right, is just going to reverse the sign of your answer, because it's like counting the base as negative. It sort of seemed like that was a weird thing to define, but it happens quite naturally with a lot of u substitutions, because when you change the limits of your integration, very often you end up with a situation like this, where you're integrating essentially from right to left along the u-axis. Okay. All right, the -1 sine x dx became my du. My integrand is square root of u, which I'm going to write as u to the 1/2. And so I'm going to say this is -1 times u to the 3/2, divide by that new power, so that's multiplying by 2/3, and we're evaluating between 0 and 1. Respect that order. Okay. So that's going to be -2/3 times what I get as 0 is 0, minus what I get at 1 is 1. So that's -2/3 times -1, and that's +2/3. That's how I would probably do this problem. Some people really don't like to have these limits of integration backwards like that, going from the bigger value to the smaller value. Since I know that what that does is reverse the sign of the integral, if I want to, I can use this negative sign to flip it and say this is equivalent to the integral from 0 to 1 of u to the 1/2 du. So that's always an option if you want to flip the limits of integration. If there's already a negative there, that just, you're using that negative sign to do that. If there wasn't already a negative sign there, I'd have to introduce one when I switched the limits. And then I just get 2/3 u to the 3/2 evaluated between 1 and 0, and that's 2/3 times 1 minus 0, which is 2/3. So I'll get the right answer either way, but you need to sort of decide, am I going to just stick with these limits where I'm going from bigger to smaller, or am I going to flip them? If you don't flip them, make sure that you respect the order of subtraction when you're evaluating things at the end.